You're welcome back. Today we want to be looking into some questions from the past question, rather. So we have a set on the board. So as we can see, these are the questions that are taken from WAEC past question. So we have here 2006 question 1. So if P is equal to the set of X such that X is greater or equal to 1 and X is less or equal to 6, and Q is the set of X such that X is greater or equal to 2 and X is less or equal to 9, where X is a member of R. Find P intersection Q. Now, to solve a question like this, we need to list out the set of the beginning set. We have set P, which is the set of X, and we are told that X is greater or equal to 1. Since we have X is greater or equal to 1, then your element is starting from 1. And if we can see the upper boundary there, X is less or equal to 6. Since X is less and also equal to 6, which means the last element there is 6. So we are listing from 1 to 6. 1, 2, 3, 4, 5, 6. So these are the members of set P because X is greater or equal to 1. X is more than 1. So what are the elements that are more than 1? We have 2, 3, 4, 5, and so on. But that same place, we have been told that X is equal to 1, meaning we start from 1. And it means the examiner is not putting the equality there that X is equal to 1, or we say X is greater than 1. That is, the first element is going to be 2, a number that is greater than 1. But in this case, X is more than 1 and X is also equal to 1. Then we start from 1. We need to know where we are going to stop. That is why we have the upper boundary. Where do we stop? And if the examiner is telling us that X is less than 5, then less than 6 rather, then a number that is less than 6 is 5, meaning we stop at 5. But in this case, X is less than 5, but it's also equal to, less than 6, but it's also equal to 6, meaning 6 is our boundary there. So that is P. Q in the same way for Q, for P rather, we have X is greater or equal to 2. So I know you will tell me that our first element there is going to be 2 because X is more than 2, but it is also equal to 2. X is equal to 2, but also more than 2. 3, 4, but we need to know where to stop. That is why we need to go to the upper boundary. What do you have in the upper boundary? We have X to the less than or equal to 9. For that equality sign, which means we stop at 9. 5, 6, 7, 8, 9. So these are the members of set Q. So, and the examiner is asking us to find P intersection Q. So to get P intersection Q, we look for the common element. As you can see, 2 is common, intersection, what they have in common, intersection 5, and lastly 6. These are the intersection between P and Q. So let's list it out. We have 2, 3, 4, 5, 6. So this is what we refer to as P intersection Q. P intersection Q. Okay, we have P intersection Q to be 2, 3, 4, 5, 6. Now look at the form we have our answers. As you can see, this X is greater or equal to 2, and here X is less or equal to 6. This one is having 6 inclusive, this one is having 2 inclusive, that is from 2 to 6. Here is from 2 to 6 is not inclusive, to 5. And here 2 is not inclusive because there is no equality sign there. And here, 6 is not inclusive, there is no equality sign. This means a number that is greater than 2, which is 3, and a number that is less than 6, which is 5, meaning from 3 to 5. Here, we have x is greater than 2. 2 is not inclusive as a result of the equality sign that is not there. And here, x is less than or equal to 6. 6 is inclusive, meaning this starts from 3 to 6. As you can see, we have 2 to 6, which is A. So we say it's still the same thing as us having the set of x. So we can say that P intersection Q is a set of x such that we have x to be greater than or equal to 2. Okay, we just say that P intersection Q is the set of x such that x is greater or equal to 2, because 2 is a member of this P intersection Q, and x is less or equal to 6. Equal to 6 because 6 is also a member. So option A is the correct answer. Option A is the correct answer. Okay, this is another question. This is question year 2010, question number 24. We have in a class of 50 pupils, 35 like science and 30 like history. What is the probability of selecting a pupil who likes both science and history? This one has a little touch of probability, but bet you it is a very simple question. So what's the probability of selecting a pupil who likes both science and history? So in this case, number of universal set, that has to do with the total number of students in that class. We refer to that as 50 students. Number of people that like science, that is number of S, if S is representing number of students that like science. So we have how many are they? They are 35. And also number of students that like history, they are 30 in number. So from here, we need to get the intersection. To get the intersection is very direct. Just have number of the universal set is equal to number of science plus number of history minus number of S intersection H. Do you know why we have it this way? Because in the number of science, we have some students that are also doing history. In the number of history, we have some students that are also doing science. That is, we have intersection here, we have intersection here. One intersection is needed. That is why we have to subtract number of science intersection history. So, and don't forget, this is just involving two sets. That is why it is like this. In that case, we have 50 to be equal to 35 plus 30 minus number of S intersection H. Then in this case, permit me to use this case, please. In this case, we have 50 to be equal to 65 minus, let's refer to it as X. Then X will be equal to 65 minus 50, that is, X is equal to 15. So, the intersection between science and history is 15. And let's look at the question. What is the probability of selecting a pupil who likes both science and history? These are people that like science and history. What is the probability of selecting a student that likes science and history? So we just have that correct. probability of selecting x now will just be equal to number of x, if you can recollect from your probability, all over number of the universal set, because we are talking of part of the universal set. Then in this case, we have number of x to be 15, which is all over 50, and that gives 3 all over 10. That is, the probability of selecting a student that like both science and history is 3 over 10. The probability is 3 over 10. And that is converted to decimal form. We have that to be 0.3. We have that to be 0.3. So, which is option B. Option B. Option B is the correct answer. Okay, let's quickly look into question 3. We have which of the following cells is equivalent to P union Q intersection P union Q. This is a bonus anyway. We have P union Q intersecting P union Q. So this is the answer, is P union Q. What does P union Q and another P union Q, what do they have in common? Is still that P union Q. For instance, let's say P union Q is equal to ABC set ABC, and don't forget P union Q, the second one will still be the same thing, ABC. So now telling us what does P union Q and another P union Q, what do they have in common? So it will just be in common. It's still the set P union Q, that is A, B, C. So it's still P union Q. What P union Q and another P union Q have in common is P union Q. That is option C. Okay, we have another question here, question number 4. If P is the set of x such that x is greater than -2 and x is less than 5, and Q is the set of x such that x is greater than -5 and less than 2, a subset of the universal set, which is the set of x such that x is greater or equal to -5 and x is less or equal to -5. Let's start with the universal set. Let's list the elements of the universal set. We have the universal set, that is the set of x ranging from -5 to 5. Ranging from -5, because -5 in the sense that x is also equal to -5. Ranging from -5 to -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So these are the members of the universal set. Let's list the members of set P. The members of set P, as you can have it there, x is greater than -2. That is to tell you x is not equal to -2. What is the next number that is greater than -2? The next number is -1. -1, 0, 1. Let's see, where do we stop? We also learned that x is less than 5, which is x is not up to 5. But what is the immediate number that is not, immediate number to 5? That is 4, which means we stop at 4. 2, 3, 4. These are the members of P. So we need the members of Q also. That is, x is greater than -5, which means the first number there is -4. -4. X is not up to 2, which means the last number there is 1. From -4 to 1. -3, -2, -1, 0, 1. That's the last number. It's not up to 2. Then what do we need? Okay, find P. union Q. You know what we call union? Listing all the elements that P and Q have. You list every element, what they have. So in that case, -4 is the least between P and Q, which means starting from -4, and +4 is the highest. So which means we list from -4 to +4. When we list from -4 to +4, we have 7.